Today we'll get started with the descriptive statistics, okay? And as part of this, first let us understand what is statistics. What is statistics? Can someone tell me what is statistics? I could see that couple of students are from statistics background, having statistics background. What is the statistics? Statistics is science, right? It is a branch of mathematics. As part of statistics, what do we do? What do we do as part of statistics? Simple, we do statistical analysis. If you have any data, you need to do the statistical analysis. For that, you need to have the data. So what is the difference between data analytics and statistical analytics? Simple. In the case of statistical analytics, we apply the related measures. Statistics related measures like mean, median, mode, standard deviation, measures of dispersion, and measures of central tendency. All those things you will apply on the data. Okay. In addition to the conventional data analytics, what we as part of data, simple example is, as part of data analytics, what we do. We want to find out top 10 products by profitability, by sales. Okay. And top 10 customers by revenue. Okay. Top 10. So you might be dealing with hundreds of customers, millions and millions of customers. In the case of Walmart, right, they are dealing with millions, and they want to see, who are the potential customers. They want to see the top 100 customers based on the revenue and the margin we got it from them. Okay. And also they come up with some kind of customer loyalty. As part of customer loyalty program, they will be offering more discount, reward points. They can, accrue all the things. Okay. So basically you wanted to have the data, right? That is the prerequisite, important prerequisite. Once you have the data in place, what you're doing is you conduct analytics. It could be data as part of the data analytics. We do the statistical analytics also, right? Like top 10 customers, bottom 10 customers, or bottom 10 products. You do analytics. What do you mean by bottom 10 products? You sell products, but there is no profitability, right? You could see that you are putting a lot of effort selling your product, but end of the day, the no profit. Okay. And so in that case, what will happen? Negative profitability. So in that case, only when you do analysis, visualize the data, you will get to know what products you need to select, what products you need to discontinue. Sometimes, yes, we want to get rid of from some products, because those products, there is no point in selling it. You could see a negative profit, right? So better you can, unless you monitor and measure what is going to happen. You are going to, if you don't discontinue the products which are giving the negative profit, what will happen? If you blindly close your eyes and if you keep sell that product, end of the day, it will have it on your profitability, right? So that is where the data analytics plays in. But apart from, so you cannot make every decision based on the conventional data analytics. So you need to use some techniques like statistical analytics you need to apply. You need to use the measures like statistical measures. You may have to predict the future. That kind of situation, the predictive analytics, everything comes into picture. Okay. So what is a statistics? It's a branch of, it's a science, and it's a branch of mathematics. It deals with collecting, interpreting, organizing, and interpreting the data. Okay. The numerical data. Okay. And the organization of numerical data, not only the numerical data, we use categorical columns also. But end of the day, we apply the statistics on the data. Okay. For that, you need to collect the data. You need to have the data, right? So only when you have the data, having the data alone not sufficient, you need to analyze this, how good the data is. Okay. Once you analyze the quality of the data, next step is you need to interpret it. Okay. The data seems to be some, the data, we can see some kind of issues. We have duplicated records and missing values are there, outliers are there. The next step is you need to address it. You need to fix that. Okay. And then you need to interpret it. What do you mean by interpreting it? So by looking at the data, you will be able to understand the distribution of the data, right? When you understand the data, when you plot the data, and if you look at the distribution or pattern of the data, if you see any skewness, skewness or kurtosis, based on which you can interpret. Okay. So, and also we have various techniques like Chebyshev's theorem. Various theorems are available. By applying that, it will simplify your task in terms of interpreting the data. Okay, various statistical tools and techniques are available, right? And also once you interpret that, you need to present it, because you cannot expect the top level people in your organizations are very good in statistics. Okay, you need to present it to them in PowerPoint about your interpretations. Okay, and also organize the numerical data, right? So you need to organize the numerical data, and using probability theory, what we do is we will make a prediction, right? We will make a prediction. Apart from that, we have the predictive analytics, predictive models, right? Like linear regression, logistic regression, using which also we can predict the future. Okay, so this is what statistics is all about. Okay. Next one is, as part of statistics, there are two branches are there. One is the descriptive statistics, other one is the inferential statistics. What is descriptive statistics? What is descriptive statistics? What is inferential statistics? So as the name suggests, we are going to, apply some measures, right? Descriptive. We are going to describe the data. Okay, as part of descriptive, we will be summarizing the data. Descriptive statistics is nothing but summarizing the data. Inferential statistics, something like we are going to take the sample and we are going to estimate the population. You just park these 2 points at your mind at this moment. Before I dive into I dive into explain what exactly descriptive statistics, you need to understand certain basic things. Maybe it's a prerequisite. Okay, you need to understand the types of data, different types of data, and different levels of measurement or scales of measurement. Before we dive into descriptive statistics, you need to understand those things. Okay, different scales of measurement. There are 4 different scales of measurement, levels of measurement is there. So here, see, for the simple example is, for example, how do you measure? What is the scale of measurement that you use it to measure height of a person? How do you measure the height of a person? Can someone give me an answer? It can, it need not be exact, correct answer. We are not going to evaluate based on I'm not going to give you mark and all. Okay, you can make mistakes, no problem. End of the day, are you all opening up your mouth? That matters a lot. For example, I want to measure the height. What scale of measure that I'm going to use it? Say height, right? Height of a person. Can we say centimeter, right? We can measure it in terms of centimeter. Let's just one guy, is 174 centimeters. He's a tall guy, right? 174, 184, and some guys are 164 centimeter. Or we say in terms of feet, we say 6.2 feet. Sorry, 6.2 feet. Or some people we say 5.6 feet. Either use the centimeter or feet. Right? Is there any other measure that are we going to use it? No, right? Can we say a person is 6.2 kgs? 6.2, that is weight, right? Weight, we use different measure. So weight, we say in terms of kgs or pounds. If somebody is asking you what is the height of, what is your height? Can you say something like, I'm 5.6 feet, so instead of saying 5.6 feet, I'm 5.6 kgs or pounds. You will say what? Can you repeat? I asked your height, not weight, right? So if you again repeat it, my height is 5.6 kgs or pounds, does it make sense? No, right? For weight, if you say, yes, I'm 50 kgs or 60 kgs or 80 kgs, it makes sense. And again, you cannot say my weight is 80 feet. You cannot say 80 feet or 80, right? 80 feet, you cannot say, right? So it doesn't make sense. For different, variable, we use different scale of measurement. Okay, so these are the 4 different scales of measurement. We use it to interpret the variables. Okay, what is a variable? A variable is, as the name suggests, right? It can take different values across your data set. Okay, a variable. Okay, so there are 4 types of scales of measurement. One is the nominal, the other one is ordinal. What is nominal type of variable? Can someone tell me? Statistics students, can someone tell me? What is nominal data? College student, because you're all fresh student, right? What is nominal type of data? So why do we use nominal type of data? Why do we use nominal type of data? Okay, what is the advantage of this? And what is the what is nominal variable is all about, or nominal data? Just give me a second. I have some issue with this. Just give me a second. Okay, I think this one is not working. Let me. So nominal variable used only used only to classify or categorize your data set. Nominal type of variables or columns are used to classify or categorize your data set. What do you mean by classifying and categorizing it? For example, this is my data set. So here I have the order number, order date, customer key, all the things are there. Okay. And somebody is asking you, this is my order transaction, simple retail data. Okay. If somebody is asking, hey, I wants to know how many number of orders raised by male and female. Is there any way we can categorize male and female with this data? No, it is not possible. You need to have the gender column, or you need to have a column by the name of sex. Let's this order was raised by a male. Okay, let's say I put M here, and this order was raised by female. And again, this one is part of your thing, right? And the same order, female. Why it is same order? The order number is this one. The single order, they raised two products. They ordered two products in a single order number. Okay. So here, with the help of the product line number, we can identify, what are the products ordered by, or any specific product ordered in a specific order. So order number, product line number, and product key you can find out. So these two products were ordered in this order number by a female. Okay. So if you have a column in addition to this, like a sex column, you will be able to categorize this data. So you can tell one male and one female bought this product, right? One male and one female. So you need to use count, distinct count on this column. Okay. When you use a distinct count, one second. Okay, let me do one thing. Okay, this is the column, right? 1 second. Let me just do one thing. Okay, and this is the column. So using this column, we can classify how many, which all orders raised by male, which all orders raised by female. Are you all agree with me or not? Are you all agree with me or not? Sushmita says yes. Aishu says yes. Jamal says yes. Pradeep says yes. Yes, yes. Please make it interactive. It's all in your hand. Okay. So you cannot using this column, we can categorize or classify these transactions, right? How many transactions are there? For example, okay, for the sake of your understanding, I'm going to change it as this is another order. This I'll just say this is going to be male. Okay, this is a different order. Okay, and line number is 1. Each order, they order only one product. Okay. So now you tell me how many male, how many female they order. All of you, please type it in the chat window. This is how I can make sure that you're all concentrating. What others? Can someone tell me? Yes, very good, right? Kripa answered. She's saying the two, how much? Two males added and two female added, and Ashik correctly. Xiaomi says not possible. Yes, Prem says not possible, because if I hide this column, if I don't have this column, we cannot categorize this data set. Let's say your manager is asking you by giving this data set, hey, how many females or how many males ordered? Okay, can you tell me that? How many transactions were made by male and female? You cannot tell. After introducing this column, you can tell 2 males and 1 female. Two transactions were ordered by male. 1 transaction was made by female. You can tell. So the sex is the nominal variable. Sex is called as your nominal variable. This is one of the examples. Okay. So using sex, you can categorize the data. So what is the nominal variable? Why we need to use nominal variable? Nominal variable or nominal value that we can use it to classify or categorize your given data. What is my given data? Given data is order transactions. In these transactions, if I wanted to know how many females are raised an order, how many male raised an order, you need to have a column called sex. Without sex, you cannot classify that. The sex is a nominal variable. It falls under the nominal variable. Okay, yes, all of you are correct, right? So I could see that Aishu, Deepa, Raji, Sai Sudha. Okay, very good, very good. So all of your response is very good. And how about others? How about others? Statistics students. Okay, forget about me. Okay, how about others? Okay, good. So nominal is a type of variable which is helpful to categorize or classify your data. Okay, and what other examples you can specify it for a nominal variable, like sex? Can you give any other, or gender or sex, right? Can you give me some other examples for nominal type of variable? Any other type of variable? Any other? Okay, specific type of variable, that is fine. What type of variable is that? Okay, well, how it is helpful, right? The nominal data or variable, you can use it to classify the data into different groups. We can say that also. And each categories are mutually exclusive. Each categories are mutually exclusive. Male is different from female, right? Each category is mutually exclusive. But if you take the distinct value in the sex column, male and female only are there, right? Unique values. Though M is duplicated, if I ask you, can you give me the distinct values in this column, you will say male and female only are the unique values. Okay, these values are mutually exclusive. M is different from F, F is different from M, right? Mutually exclusive. Okay, and nominal data is also called as a categorical variable or qualitative variable or non-parametric. They use different terms. You need to be familiar with all these terms, okay? And here the nominal is also called as a categorical variable. Sex is a categorical variable. And what other things? Gender, categorical. It is also called as a categorical variable. Sorry, not gender. Sorry, categorical variable, or this one, the qualitative, or yeah, categorical, qualitative, or non-parametric. They call it as a non-parametric. It is also called as a categorical or qualitative or non-parametric. Okay. In the case of nominal type, so what other examples you can give? For example, I have something called color, right? Color. You can say color, and this one, the shipment status. You have something like yes or no, right? Yes or no. So, for example, in this thing, I'm going to add another column, shipment status. Here it says yes, no, yes. Can someone tell me, is this a nominal type of variable? I'm going to create a few other columns. This I'm going to create another column called region. The region is north, south, and east. And this guy again north, another guy is south. Okay, we have few more orders. I'm going to the same day, maybe in different orders, they have raised different products. Maybe same product. Okay, and here female is there, and here I just say you ordered 3 products. Here he added only 1 product, something like that. Okay, So these are the different columns, right? Different columns. But can someone tell me, are these columns are also categorical or not? Yes, the categorical variable. It is a nominal type of variable. It is a nominal type of variable. I could see a lot of response. Very, very good, right? So delivered or not. Kruba and Fatima says yes, and true or false. Other example is yes, he has given high or low, right? So in the case of stock market, right? So we can say high, low, and nominal. In the case of commodities, yes, nominal, right? So commodities market, we can use a mutual fund. For example, mutual fund. You have the case of mutual fund data, different mutual fund names are there. And the different assets are there. But against that, you specify the risk, mutual fund risk, whether it is high risk or medium risk, low risk. But that is slightly different. Okay, the high risk, medium risk, low risk, I will explain it a little later. So these are the examples for nominal type of variable: shipment status and region, and these are the and sex. These are the examples for nominal type of. Here basically we are using these columns to categorize your transaction or classify your transactions. If somebody is asking you, can you tell me how many number of orders we raised it and we received it from North region? How many number of orders we received it from South region? In South, we have received in total 3 orders. In North, we received 2. And how many orders we are yet to ship? How many orders we shipped it? How many orders we did not ship it? Using this shipment column, you can, by applying a filter on this, we can say we have shipped only 3 orders. Remaining 2 orders we are yet to ship it. Using this categorical column, you can classify your transaction, your data. This is what your nominal type of variable. Can I apply average? Can I do average on this column? Can I do average on this column? Can I sum this column? Can I do total? Does that make sense? No, right? Can you add y plus n plus y? It doesn't make any sense. If I use sum or mean is in statistics, we call average as mean. Yes, Rupa, 1 second. I'll write it here. In statistics, we call mean. Okay, mean is nothing but average. MEAN. Okay, it's average. Typically, we call average, but in statistics, we use a term called mean. It's nothing but average. Can you find out average on these columns? You cannot. Because it's all text value. Okay, let's say I want to do some kind of encoding. Instead of using a text here, I'm going to say male is 1 and female is 0, 1, 0, 0. This is the typical code that they use it for gender column. Okay, 1 is nothing but male, female is 0, 0. Okay, this is the code. This is the one conventionally used in most of the statisticians. What is this one? What is this one? 100. It's an encoded value. It's nothing again. So the sex column, instead of having the text value, we have the numerical value 10100, right? You can have this way also. Not necessarily your nominal column should have text value. It can also have numerical value in it. 10100, something like that. Okay, you can have this. So 1 is nothing but male. Different enterprises or different organizations, they use different values, even in the case of nominal type of variable. Remember that. Okay, this is called encoding. Instead of using M, they encode these text value by numeric value. Why? Because in the case of machine learning algorithm, there are some algorithm, it can work only with the numerical column. You cannot use the text columns. Okay, fine. So even in this case, if I do average, does it make sense? Does it make sense? Can you tell me the average males, average females? Does it make any sense? First of all, can you find out average? Does it make sense? Even though you have numeric value, here how much, right? 2 divided by 5. So here 0.4. If you do it, 0.4. What is this 0.4? First of all, we don't have 0.4 at all here, right? So 1, 1, 0, 0 is there. You cannot, does not make any sense. Even if your nominal variable has the numerical value in it, if you do average on it, it does not make any sense. Yes, majority of you are correct. Does not make any sense. Okay. So what we concluded is, in the case of nominal type of variable, we cannot apply mean, the average. You cannot perform average. You cannot use median also. Median, yes, I will come back. So median, yeah, median, you cannot use it here, right? And how about mode? We have something called mean, median, mode. What is mode? Mode is nothing but the frequency, right? A frequency. For example, this is the one. So in the case of nominal type of variable, you can find out the frequencies. How many number of times M is occurring, male? How many number of times female is occurring? That you can find. Number of occurrences you can find out. Let's say male 2 records are there, female 3 records are there. You can find out the frequency, how many number of males, and the number of occurrences of the values you can find out in the case of nominal type of variable. And also you can find out the proportions compared to the male. What is the female, the number of, so what is the number of transactions, or what are the proportion of transactions made by male compared to female? Yes, that is also you can tell, right? So frequencies and proportions, you can use it on top of a nominal type of variable. You cannot find out average. Mean is not going to work. Median is not going to work. You cannot use standard deviation. Remember this. Okay. And what else? So the next one is the, hope you understood with this, right? The next one is the ordinal type of variable. So what is ordinal type? Ordinal type of variable is also called as the same thing, categorical variable, or the qualitative variable, qualitative, or categorical, qualitative, or non-parametric. I will explain you what is parametric, non-parametric later. Categorical, it is also called as a categorical or qualitative or non-parametric. Same as your nominal. But what is the difference between nominal and ordinal in this case? Can someone tell me what is the difference between these two? You just type, any value, anything in the chat window. Okay, chat window is for typing anything. Okay, so here there is no right or wrong answer. You are not going to get any mark if you give wrong or right. Okay, I wanted to see how many of you are taking initiative. 1 second, I'm getting some calls. We rank the ordinal, okay, or order the ordinal data. Okay, Krupa answered correctly. Okay. Okay, give me some example for ordinal type of variable. Give me some example for ordinal type of variable. For example, you have something called customer feedback. Customer feedback. Let's say if they rate 1, that means outstanding. The taste is, food quality is outstanding. 2 is very good. 3 is poor, and 4 is very bad. Okay, this is poor, this is bad. So in this case, can we call this variable customer feedback as this one? What is that? Customer feedback as an ordinal variable? Yes, it is an ordinal variable. Why can't I call this a nominal type of variable? But in this case, the column customer feedback, inherently it has order in it. Inherently it has some order in it. Yeah, 5 scale or 7 scale. Yes, Krupa says yes. Out of sorry, okay, I will write it here. Let's say you have something called customer feedback column. Here's something called customer feedback. Some customers, customer E is given the feedback as 1 about your food quality, and he has given rating 2, and again the other customer C, right, he has given your quality as 3, and let's say D is they've given 4 on a scale of So on a scale of 5, 1 being outstanding, 2 is very good, 3 is poor, and 4 is very bad. Okay, let's 5 is let's assume that 5 is something else. Okay, it's a very it needs improvement or something like that. Okay, so 1 is outstanding. Okay, and so this column customer feedback is an example for classic example for ordinal type of variable, because here the order matters. Here the order matters. 1 is superior than, can I say 1 is superior than 2? Yes, obviously, right? So 2 is superior than 3. Can I say yes? But here, let's say I have a color column, right? So in the color column, I have red, green, yellow. So can I say, or we have a region column. Can we say north is greater than south, south is greater than east? We cannot say, right? We cannot say here. Or can I say female is superior than male? No. Here there is no order comes into picture in the case of nominal type of variable, whereas in the case of ordinal type of variable, the order comes into picture. The superiority rank comes into picture. Okay. What other examples you can give it here? The customer satisfaction, CSAT, we call that as a CSAT. We use a term called CSAT. It is nothing but the customer satisfaction. Apart from you have something called, in the case of mutual fund as investments, right? It will be rated as interest, something like high risk. There are some mutual fund risks are very high, right? So we say high risk. We have something called risk type, high risk, low risk, medium risk, and low risk. Okay, high is 1 and medium is 2 and low is 3. Okay, this is another example for ordinal type. In this, yes, this is superior. If if I buy this mutual fund, the risk is very high. Okay, I'm going to lose a major amount of money, right? In that case, right? So if I invest on this mutual fund, it involves high risk. Okay, so here it is superiority comes into play. This is superior than this one. So the risk is much higher than this one. The medium risk is much higher than the low, right? So here also the inherently it has some order in it. Okay, inherently, and again the defect severity in the software industry, right? We say defect severity. After you have developed an application, the QA team, they test your applications. Or even in the case of manufacturing unit, let's say the machines produce the finished goods, and when the quality inspector inspecting each and every product, right, they put it, the defect severity is very high, 1. So right, so medium, very high, and these are the products very high, because if we deliver this to our end customer, they will be completely dissatisfied. It requires urgent fix. Even the case of software, right? So this has defect severity is very high, because it is going to have a serious impact on the business. Okay, the defect severity is high, and this is something like medium, and 3 is low. So this one requires maybe, right, you can take 2 days to 1 or 2 days time, but or 2 to 3 days time you can take it to fix this error. Whereas in this case, you need to fix it within 1 hour, within 1 to 2 hours. Okay, they say all the jobs are running in the production system. If any one of the job fails, right, so they classify something, or in even the case of testing, right, we come up with something like a defect severity. So in this case, the defect severity is 2. So maybe it requires 1 day time to fix that issue. Okay, for this, within hours you need to fix it. Okay, because this may cause a serious impact on your business. Okay, the defect severity is another, because here, 1, 2, 3. 1 is superior than 2, the severity, right? 2 is superior than 3. So here you can compare the values here, right? So the which one is here? The superiority comes into picture. Superiority. Inherently, these type of nominal or these type of categorical variable have order in it in the data. So that is why it is called as a ordinal type of variable. Though we call nominal as well as the ordinal type of variable as a categorical or qualitative or non-parametric variable, the difference is in the case of ordinal type of variable, it inherently has an order in it. That's it. So next one is the interval type of variable. So what is interval type of variable? What is interval type of variable? The interval is something like, the distance between two things, right? The distance between, you just think that, right? In the interval is something like the interval data is also known as a scale, right? The quantitative or parametric. These two are called quantitative variable or parametric variable. This is your qualitative variable. We say qualitative and quantitative. Okay, these two are different. Here, what we can do is in this case, in this type of variable, we can apply mean, median, standard deviation. Can someone give me the example for interval? First of all, what is an interval? Interval, intervals are something like a distance between two things. Okay, distance between two things. So what are they? What are they actually? So using interval also, we can categorize the data, we can rank the data, and it is evenly spaced. The interval type of data. Okay. In the case of interval data, you can perform addition, subtraction, like calculating time differences or temporary changes. You can temperature changes. Okay. Temperature changes we can find out here. The temperature is the classic example for the interval scale, right? In the case of the temperature, for example, what is the difference between 30 degree and 40 degree? Let's say 40 degree to 50 degree. So the difference between these two are same, right? Here you have 10, here you have 10. The interval 30 to 40 degree and 40 to 50 degree, the interval is 10, right? So 10, 10. So those things you can evenly space out, right? 30 to 40, 40 to 10 consistently, 50 to 60 degree, something like that. This is kind of your interval type of data. Okay. But in the case of interval data, right? So in the case of interval data, you can do the categorization. How do I do that? So let's say, another example is age. For example, between 18 to, so let's 17 to 20 years, and 21 to 25 years, and 26 to 30 years. Even in the case of interval, right? We can categorize this data. So can you tell me the customers age between 17 and 20, how many number of orders they raised it so far, or what products or how many number of orders raised by people with this age group? In this age group, how many number of orders we received? In this age group, how many number of orders we received, or how many number of returns we received it? So very well, the e-commerce website, we can raise an order. Not necessarily all the orders needs to be bought, right? So the customers can return it also, right? Let's say you order the products and you return it because you did not expect, or because of defective pieces, they delivered it with some defects, it is broken, right? So you want to return it. So in each age group or bucket, how many number of products we have ordered, how many number of products returned by the customer. So likewise, using interval also, you can do the categorization. The interval values are evenly spaced. And also you can think about the interval type of variable as your continuous, discrete type of data, right? Discrete, instead of saying discrete, I'm going to say, so this one I'm going to call as a continuous data. Here's something continuous variable. I can say continuous variable. I'm going to say this kind of, we can say discrete variable, right? Discrete variable. Can we say like that? Discrete variable. So what do you mean by discrete variable here? What do you mean by continuous variable? One second, somebody is calling. Just give me a second. Yes, someone is. Here, Okay. Sorry. Okay. Single variable is called your discrete variable. So give me an example for a single variable. Single variable. What do you mean by single variable? Is that correct? So give me an example for the, some, data for this one. Give me some column name, some variable name for this. What is this? Okay, I will just, so it can also be called as a discrete variable, or you just think this is a kind of a whole number. Okay, whole number here. Okay, here there is no decimal comes into picture. For example, how many number of kids born in the labor ward? In a hospital, you have a labor ward, right? So there, when the senior staff nurse visits inside the labor ward to take stock of how many kids born since morning. Okay, let's say she visits by 3 p.m. in the afternoon, and she's asking the other nurse, right, how many number of kids born since morning? She will say 8 kids, or she will say 10 kids, or she will say 6 so far. She will not say 6.66 kids born, right? It doesn't make any sense here. Okay, we don't say 6.6, right? We can say the whole number, 8 or 10 or 6. We don't say, 0.6. Any other example for the discrete variable? It's kind of a whole number, okay? How many number of defects? You have a column called number of defects. So in your data set, you have mentioned each product name. Against that, you put or along with that, you put a column called number of defects. You are a quality inspector. You tested each and every product. You will say either number of defects in first batch, batch 1 or something like that, batch 1, batch 2, number of defects 4, number of defects 8. You will not say 4.44, right? So these are the examples for the number of books. Yeah, number of students. Very good. How many number of students are there in a class? How many number of books you sell it in your shop? Very good example, right? How many customers you have it? You will never say, you are owning an e-commerce website. Yeah, number of orders. Very good. Number of orders. How many number of orders? We never say we received 122.222 orders. Very good. It's very interactive, right? So number of orders, number of defects. Other thing is number of kids born, right? So number of kids born and number of books. Yes, number of books, number of orders. These are the examples for your interval. Number of users. Very good, Kripa. Okay, Kripa says number of users. How many number of users? In my website, so your manager comes up to you, he walks up to your desk and he is asking you this question. Can you tell me how many number of users access our website since morning? You will say, so far 1,000 customers, 1,000 customers visited our website. How many number of users, number of customers visited our website, number of books, number of defects, or number of followers in Instagram, number of followers in Instagram. So these are the examples for interval. So we have an exhaustive example for this. The interview, definitely they'll ask you, okay, as part of statistics, so what are the scales of measurement that are available? Can you tell me what is a nominal and what is interval? What is the difference between nominal and ordinal type of variable? Okay, next one is, this is a discrete variable. It's kind of a, the whole number here. You just think that this is a, tip, the shortcut way of remembering this. And ratio is a continuous variable. Give me some example for ratio. Okay, before we jump in here, now we understood what exactly interval is all about. Okay, interval is all about. In the case of interval data, it allows to do some kind of, you can find out the median, right? You have number of orders, right? Let's say last 7 days data, you have it. The Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, 7 days you do the business. Each day, how many orders you received? 18, 25, 6, 8, 10, 12. Can I take the average? How many, can you give me the average orders that we received it on the last week? Yes, you can take the average. That is possible in the case of interval. It makes sense if you take the mean. And median is the middle value. Yes, it is possible with the interval type of variable. Standard deviation, yes, we can find out the standard deviation. That is also possible in the case of interval type of variable, quantitative variable. It is also called as a quantitative variable or discrete variable. Next one is the continuous variable. What is continuous variable? Can someone give me some variable name? Yeah, age, height, weight, age, height, and weight. For example, you wanted to ship your you have a wardrobe. You have a wardrobe in your house. You want to ship it to another place via some parcel service, right? What they do is they weigh your wardrobe, how much weight it has. It need not to be a whole number, right? It need not to be, it comes around 12 kgs, 0.850 gram, 12 kgs, but we say 12.850 kgs. This is the example for ratio. What other examples? Okay, polling numbers. What do you mean by polling numbers? Age, right? Age is, yeah. So you can say you are, how many, give me an example for age. What do you mean by age here? So 23 years and 10 months. Can we say like that? Election polling numbers. Okay, election polling numbers. How many number of people they polled it, right? That is the discrete variable, isn't it? There is no, see, continuous variable is something like, it will be something, on a scale, right? 0 to, the values are ranging between minus infinity to plus infinity. Am I correct? Continuous variable. Any value ranges between this. Okay, or we can say, right, 0 to infinity, right? It can be 0 to infinity. Maybe, right? So between 1 to 2, it can be 1.1111, right? So how many values are there between 1 and 2? So we can say 1.01, 1.02. Likewise, the values are continuous here between 1 to 2 itself, right? That is the reason we say continuous value, which means it's that, it involves some kind of decimal value here also, right? Decimal value in this case, okay? 12.33 something. The height is 172. You can say 170, or your height and weight. We can say weight is this one. Height, can we say height is ratio? Can we say height is a ratio or discrete variable? The other example is hours spent. Hours spent. Number of hours built. In the case of software industry, right? Every week, Friday, we are going to charge the customer. So this week, every day, 8 hours. So every Friday, it comes in 5 into 8, 40 hours. Sometimes 40 hours, 40 hours, 0.30 also we can say, right? Hours. Okay, we can say for, or, how much hours you spent in studying, right? Hours spent in studying. You can say that 5.30 hours you spent. We can say that one also. These are the examples for your continuous variable. Yes, height is a discrete, right? Discrete variable. And whereas, height, can we say height is a discrete variable? Is that correct? How many of you agree with, this reply? Someone replied saying that height is a discrete variable. Weight is a discrete, the weight is a continuous variable. Height is also continuous variable, right? Height is also continuous variable. We can say, short, we can say, if you specify it in terms of categorical thing, right? Nominal value also you can use it, the height. So here, height in terms of, the short, medium, tall. We can classify that way also, height, right? But when you specify, when you quantify that height, right? 6.2 feet. You will say 6.2 feet. Height is also continuous variable, 6.2 feet. You never say no 6 all the time. We cannot round it up, right? All the time, right? You can say 6.2, 165.3 centimeter. So height, hours spent, age, weight. These are the example. How about the wages, salary? Salary or wages. This is another income, right? This is also a continuous variable only. Any other example? These are the examples. So now we understood the difference between interval and ratio. At the high level, you just think this, discrete is a whole number. This is your, decimal. It involves some kind of decimal. Okay. These are the example. Another example is like distance. Distance is also another example for your ratio, right? Distance is also another example for ratio. Weight, height, time. How about time? So that's what I mentioned, 5.3 hours. And distance is also a ratio variable. Got it? So now you understood what is the difference between the nominal type of variable, ordinal type of variable, interval and ratio. Okay. And so ratio is a type of a quantitative variable. Okay. It almost have all the properties of your the interval variable, but here it has a clear or it has a clear and meaningful 0 point. It has a clear zero meaning. Zero has some meaning here. Zero has meaning in the case of ratio. What do you mean by zero? Whereas here, in the case of interval, zero has no meaning here. Can someone tell me what is that? What is that meant for? Zero has a meaning here. For example, how much balance you have it in your account, bank account. If you say zero, it makes sense, right? You need not to have balance in your account. In my application, if you say, I know I have zero balance in my account, that means it makes sense. Can I say here, what is your height? Can you say, zero? Can a person have zero height? No, right? Here zero has no meaning, whereas here zero has meaning. Okay, if I say, balance, account balance is my account balance is zero, that means it has a meaning. Zero has a meaning in the case of ratio. And in the case of interval, zero has no meaning. For example, what is the temperature now? Can we say zero? 0 degree, it is possible, right? Right? So zero has a, meaning. Can we say zero has a meaning here? Right? Zero has meaning here. Here zero has no meaning. What other example we can say? Height, right? Height is the classical. Weight, height and weight. If I say my weight is zero, my height is zero, does that make sense? No, right? Here zero does not make any sense, whereas here zero has true meaning in the case of ratio. Okay, so now you understood what is nominal, ordinal, interval, and ratio. To summarize, the nominal, using the nominal and ordinal types of variables are also called as categorical or qualitative or non-parametric variable. Still, I'm yet to explain what is non-parametric. I will explain it later. Okay. And what is this one? The interval and ratio. Interval is also called, interval is also called as a discrete variable, whereas ratio is also called as a continuous variable. Okay, continuous variable. The ratio and interval, these two data allows to do all type of arithmetic operation. You can, add the values. You can take the average, median. You can find out the standard deviation, everything. So this level of measurement, these are called your levels of measurement. This tells us what kind of With this, you can decide what kind of statistics analysis you can do with the data. With this, you can decide what kind of analysis you can do with what data. Okay, it is very much important to understand the level of measurement to analyze and understand your data correctly. Okay, it's very much important. You need to know this one. Okay. So so what is a nominal? Using nominal, we can categorize the data. Ordinal also you can categorize, as well as you can rank the variable. Interval, using the interval type of variable, you can categorize it, and you can also rank it. It is evenly spaced. How about ratio? Ratio can also be categorized, ranked, evenly spaced, and as a natural zero here, right? If you say I have my account balance is 0, that means here it makes sense. Sorry, 0 has a meaning here. Here, in the case of interval, 0 has no meaning, right? In the case of interval, 0 has no meaning, which means if I say height is 0, that does not make any sense. But in my scale, if you see my ruler, or in my scale, if you have something 0 also, right? It starts from 0 to something, 35 centimeter, right? Maximum, I don't remember it. In a scale, right? In the scale, you have this one. But how can you put 0 here? Because in the case of measuring height, the 0 does not, but this is the convention, right? It starts with 0, right? Just for the scale, we start with 0, right? So that is the reason. But in the case of height and weight, 0 does not, make any sense. So now you tell me which one is discrete, which one is continuous out of these variables. Gender, it can have either male or female, or we can encode it like a 0 or 1. Like I said, it can be 0. So 1, it's a 0, right? We can specify, instead of text, you can use the numerical value also. We call this also as a label, right? We can label the genders as label, right? So we can label the transaction as male or female, something like that. Okay. So it is a nominal type of variable. Here there is no order in it, right? And how about age? In this case, age. I put it something like this. Weather condition, starting or initial point. Weather condition, yes. Calculative, yes. Krupa, you are correct, right? So we can say weather condition. If the weather is 0. So yeah, in the case of weather, 0, right? 0, does it 0 degree temperature? Yes. In that case, it has a meaning in it. Correct. Gender, discrete, age, continuous. Very good. Discrete variable. Correct. In this case, these are discrete variable. Age is a discrete variable. Gender is a discrete variable. Can I say gender is a discrete variable? Hours spent last week. So it's a ratio. It's a ratio because we have decimal here. It's a continuous variable. Continuous variable. Performance rating. What is it? Is this a discrete variable or the discrete, right? Discrete. It has some ordinal variable. It is an ordinal. The scales of measurement is ordinal, but it is a discrete. We never say 1.111, right? Rating. We say the whole number, right? Since it is a discrete variable and it is a decimal, you just think continuous. And this is it's not a discrete, it's a continuous variable, right? You can say continuous. And it's a ratio. Okay. And gender, it is a nominal. So 1 or 0, kind of, discrete. It's kind of a discrete.